Hello, welcome back to Maths. Today we're going to be looking at matrices for the Level 2 AQA certificate in Further Mathematics, also known as GCSE Further Maths. Before we begin, we're going to go and look at some prior knowledge that you're going to need for this video. The prior knowledge is going to be two things about matrices. The first piece of prior knowledge you're going to need is that if A is a matrix and B is a matrix, A times B is not equal to B times A. Matrix multiplication is not commutative. Order does matter when it comes to matrices. The second thing that we're going to need to know is that if matrix A acts on to transform the coordinate PQ to give P1Q1 a new coordinate, if then P1Q1 is acted on by, say, matrix B to give P2Q2, there is a single transformation that will take us from PQ to P2Q2. And this single transformation is not, as most people would think, the matrix AB. Of course, it's the matrix BA. So the matrix BA acting on PQ to transform PQ will transform it directly into P2Q2. So it's important to realise, obviously, that this is true. However, it's also critical to realise that matrix multiplication is not commutative and that AB and BA are not the same thing. So I've set up three questions that kind of typify what goes on at GCSE Further Maths and will give us kind of all the different possible working outs, or most of the combinations that you could see typically in exam questions. Question 1. The transformation matrix 1, 2, 3, minus 4 maps point P onto point Q. The transformation matrix 2, minus 1, minus 1, 1 maps Q to R. Point R is minus 10, 10. Point P is AB. Find out the coordinates of point P. All I need to do is find out the values, therefore, of A and B. So let's call this matrix matrix A and this matrix matrix B. We remember from our prior knowledge, that the matrix I actually need here is the matrix BA, not the matrix AB. So I can say that BA is 2, minus 1, minus 1, 1. And I can multiply that by the matrix 1, 2, 3, minus 4. Multiplying these through, I will briefly just go over matrix multiplication. So I do the 2 times the 1 to give me 2. I do the minus 1 times the 3 to give me minus 3. And 2 minus 3 is minus 1. I then go on and say that 2 minus 1 times 2 and minus 4. 2 times 2 is 4. This is plus 4. So we get 8. Minus 1 times 1 is minus 1. And here we have a 3. 3 minus 1 is 2. And minus 1 times 2 is minus 2. 1 times minus 4, minus 2 minus 4 is minus 6. This gives me my new matrix. Minus 1, 8, 2, minus 6. I now know that if I'm taking that matrix and multiplying it by this point AB, I know the result. I know the result's actually going to be minus 10, 10. However, I can just carry out my matrix multiplication. Minus 1 times A gives me minus A. 8 times B gives me 8B. Similarly, 2 times A gives me 2A. And minus 6 times B gives me minus 6B. But I actually know that this is, the resultant is minus 10, 10. I can therefore use this to set up two simultaneous equations. I can say that minus A plus 8B is equal to minus 10, and I can say that 2a minus 6b is equal to 10. If I call this equation 1 and this equation 2, I can then, for example, I could double equation 1 and get minus 2a plus 16b equals minus 20. I could then add these two lines together. This will get rid of my a's. Minus 6b plus 16b gives me 10b. 10 plus minus 20 gives me minus 10. Dividing through by 10, therefore b is minus 1. And then we would just substitute back into, doesn't really matter where we substitute back into, let's substitute into 2 above. So we'll substitute into this one. B is minus 1, so I would end up with 2a minus 6 times minus 1 equals 10. This gives me 2a plus 6 equals 10. 2a equals 4. A equals 2. So the coordinates of the point I want are 2 minus 1. So that's question 1. Let's look at the second question. Transformation matrix maps point P to point Q. The transformation matrix, here we have another matrix, maps point Q to point P. Back to point P. So this point is invariant across these two transformations. The point P is A4. Work out the value of A. Okay, again, I can approach this much the same way that I did before. I can say, well, if I let this matrix be matrix A and this matrix be matrix B, then I know the matrix that I want to see is matrix BA. That will be the single matrix that will transform point P back to point P. So I need to do this this multiplication. So here we have matrix B, here we have matrix A. I multiply them through, and this is going to be very, very simple. I think I get 0 here. I get that one times that one's minus 1, and this is minus 1, and this is 0. So this is now the matrix BA. I'm now taking the matrix BA. I'm multiplying that by point P. I'm using, this is a transformation of this, but I actually know the answer I'm going to get out is actually still going to be equal to point P. I know that we start with point P and we end with point P. So I'll carry out this multiplication. 0 times A is 0, minus 1 times minus 4 is minus 4. Minus 1 times A is minus A. 0 times 4 is 0. So I've got minus 4A, but I know that actually equals, no, I'm actually told it goes back to point P, back to where it started, which is A4. And I can see from this that A is actually equal to minus 4. And that's just by equating the top numbers. A is minus 4. Equally, I could argue that you get the same answer from down here. So you can see the answers at two different places. Final type of problem you get is this question 3, where we get some sort of heavier algebra in here. So matrix A is this, A plus B 3, and matrix B is 1 3 minus 2 1. It turns out that AB is 3 2 minus 6 3. Work out the values of A and B. Now again, this looks like it will arrive at some form of simultaneous equation, but again, it's the same procedure all the time. You'll notice there's a lot of commonality in these problems, and so I'm just going to multiply A times B. So A times 1 gives me A. B times minus 2 gives me minus 2B. A times 3 gives me 3A. B times 1 gives me B. AB times 1 gives me A plus B. 3 times minus 2 gives me minus 6. A plus B times 3 gives me 3A plus 3B. I'm expanding that bracket all at once. And 3 times 1 gives me 3. So at this point, I've ended up with this matrix. However, I actually know already that this is actually equal to 3, 2, minus 6, 3. And therefore, I can equilibrate any of these. So let's pick one. Doesn't really matter which one. Well, I'll tell you what, let's do them all. A minus 2B equals 3. I can say that 3A plus B equals 2. And I can say that A plus B minus 6 equals minus 6. This last one's quite interesting. I can pursue any one of these. Let's just give them names. Let's do this properly. Taking this last one, adding 6 to both sides, I can see that A plus B must be equal to 0. I could then say that I will do, so I'll call this equation 4. You want to tell the examiner what you're doing, so I'll then use equation 2 and I'll take away equation 4. So our next one will be 2 minus 4. So I'm going to do 3A take away A gives me 2A, B take away B gives me nothing, 2 take away 0 gives me just 2, and therefore dividing by 2, A must be equal to 1. And using then this equation 4, I can say sub into 4, 1 plus B equals 0. So clearly B must be equal to minus 1. So in doing this, I've now worked out the values of A and B. That typifies the three questions, the three types of question you might see on a GCSE Further Maths paper. There's lots of resource available on this. Both are at www.milesmaths.net. And also Dr. Frost has a huge amount of stuff, and I highly recommend that you check that out. Thank you for watching. This is Miles Maths. Have a good day.